Welcome to a trigonometry revision video on angles of any magnitude. We have a whole bunch of examples to go through, so let's get started. In which quadrants is the cosine ratio negative? A lot of people have ways of remembering the all stations to Cronulla business, or all stations to Central. People around the world are probably picking some random place name starting with a C, but still. So which quadrant is cos ratio negative? Well, cos is positive, as is sine and tan in that first quadrant. Sine is negative in that second quadrant. So tan and cos would be negative, so we'll talk about the second quadrant. And tan is the only one that's positive in that third quadrant. So I think the second and third quadrants would be where the cosine ratio is negative. Second and third. In which quadrant is the tangent ratio positive but the sine ratio negative? Let's have a look. So the tangent ratio has to be positive, which is probably here and here, but the sine has to be negative. So in the first quadrant the sine is positive, so the third quadrant is the only time those two conditions coincide with each other. Find the exact value of cos 210. Now 210 is gotten by often saying 180 plus whatever equivalent angle we have from the first quadrant. Like there's an acute angle that can create 210 from being added to 180. So I think you can tell from that cos 30 is the equivalent sized angle, but it is in the third quadrant, so we have to figure out whether cos is going to be positive or negative in that third quadrant. We've still got to remember it comes from the third quadrant there. And we can go to our exact value triangles here and have a look at what cos 30 is. Cos 30 would be adjacent on hypotenuse there, root 3 on 2 for the value of it. But I think you can see in that third quadrant, cosine is negative. Tan is the only one that's positive in that third quadrant. Cosine is negative, so we'll take that value and stick a minus in front of it. So cos 210, it's the equivalent of cos 30, so we can look at the exact values triangle to get the magnitude, like the size of that value, but we have to figure out what quadrants it's in to see whether it's a positive or negative value. Exact value of sine 225. Now if you thought about 180 plus something to make 225, I think you'd be talking 45, which is one of our exact values. So sine 45, we have to remember that 225 is in the third quadrant though, so we have to keep that in mind and take that into consideration. On our 45 degree exact value triangles, we can see that sine 45, if we go from, it doesn't matter which one we go from, we have opposite over hypotenuse there, 1 on root 2, so that gives us the size of that value. But let's have a think about whether sine is positive or negative in that third quadrant. And it's negative. Tan's the only one that's positive in that third quadrant, so we've just figured out that our sine value here needs to have a minus in front of it as well. So there we have it. We could in some textbooks need this to be multiplied by root 2 on root 2 just to rationalize the denominator there, but I think we'd be able to get away with just leaving it like that. But the alternative is to say root 2 on 2 minus root 2 on 2 when we rationalize the denominator. Exact value of tan minus 135. Now that would be, this is a bit different, this one being a negative value, but tan 135 can be gotten by minusing 45 from 180. Well, actually minusing 45 from minus 180. So anyway, minus 135 is the equivalent of 45 in that third quadrant. Now the reason why we're saying it's in the third quadrant is when we've got a negative angle like that, we don't go anti-clockwise like we do with most of them. That's usually our starting point. We're going that way if our angles are positive, but we have to kind of go backwards. Actually this is clockwise now, minus 135. So if that's 90 in there, you can see that minus 135 is actually in that third quadrant. So is tan positive or negative in that third quadrant? Oh, I think it's positive. So let's have a look at the equivalent of 45 degrees as a positive exact value. We'll look at 45. Tan 45 is opposite over adjacent, or other way around, 1 on 1 for the exact value, and I think we're going to leave it as a positive because tan is positive in that third quadrant. So quite a lot of thinking. There's usually three things you have to think about. You ask what is the equivalent acute angle we're talking about, often 45, 60 or 30, and we can get the size of that exact value from our triangles using 30, 45 or 60, but we have to because theta is 5 over 8 and sine theta, another clue here, is negative, less than 0. Find the exact values of cot, sec and cosec. Okay, this will make us work pretty hard. Anytime we've got cos theta equals 5 over 8, we can draw a right angle triangle. Seeing this is the section of trigonometry we're in. And the reason I put a 5 there is because that's on the adjacent side, and that's on the hypotenuse, which makes up the cos ratio there. So that's the arrangement we've got there. And we can do, we can press in our calculator, shift cos 5 over 8 equals shift. That's because we're working backwards to find an angle. Shift cos 5 over 8 equals, and then we could press our degrees, minutes and seconds button to get a readout of the exact degree there. So that's finding the degree. Okay. In my working before, we did find the other side of the triangle in case we needed it. I think we will need that one. So we'll just do a quick Pythagoras there. Went off on a different tangent there, speaking mathematically. But anyway, Pythagoras on this, finding a shorter side, we've got a minus in between, so I'm sure you could find Pythagoras there by 8 squared minus 5 squared and then square rooting it. And because we're talking about exact values, we'll leave it as square root of 39 for that other side there if we need that later. But anyway, let's and the other thing is we've got to figure out what quadrant we're in. Now these things can be thought of in different orders, like I just demonstrated to you. Should have looked at my notes, shouldn't I? Anyway, here sine is negative, so we need a now you notice this value here is positive. It didn't have a minus in front of it, so we're looking for a quadrant where cos is positive and sine is negative, and it's that fourth quadrant that we're looking at there. So we'll keep that in mind for figuring out whether cot, sec and cosec are going to be positive values. So it depends on what happens in that fourth quadrant to cot, sec and cosec. But anyway, let's press on with the next bit. Now this is what I was talking about before. We've got cot theta. Oh, we could then well actually, yeah, okay, let's not find the okay, got a bit confused there, sorry. Bear with me. They're after just the cot and the sec and the cosec. They don't need us to find the theta as well, so we don't need to press that shift cos. We would if we were asked to find theta, but here we're just finding the ratios. So all we're doing for cot there, now do you remember what cot is? It's 1 on tan, or the upside down of whatever the tan ratio is. So you're looking at theta here. Tan would be opposite over adjacent, so we're talking root 39 on 5 for tan. So tan would be root 39 on 5, so cot will be the upside down of that. That's how we got the 5 on root 39. Do you know how we got the minus there? Well, that's because cot and tan are related to each other, cotangent and tangent, and so cot is positive and negative wherever tan is positive and negative. So in this fourth quadrant, tan is negative, so therefore cot is negative. Okay, let's have a look at sec theta. It's supposed to be, we could rationalize the denominator there as well. I'm supposed to be helping here. I think I'm confusing everybody. Anyway, sec is the upside down of cos theta. Now cos theta here would be adjacent over hypotenuse, so cos would be just cos itself would be 5 over 8, and we knew that from the original question. So sec is 8 over 5, that's where we got our 8 over 5. And notice we left it as a positive, because sec is the reciprocal of cos, and so sec and cos are positive and negative all in the same spots as well. And cosec. Cosec is the reciprocal of sine. So sine theta here is opposite over hypotenuse. So sine would have been root 39 on 8. So if we reciprocate that, we get 8 on root 39. And once again, cosec and sine are so closely related, they're reciprocal sort of ratios. And so cosec is positive and negative in the same quadrants as sine is positive and negative. So sine in that fourth quadrant that we decided we were operating in is negative. That's why we've got a minus in front of our 8 on root 39. We could rationalize the denominator as well. Boy, there's a lot to think about in that question. Anyway, anytime you've got two sides and a right angle triangle, let's just use Pythagoras and find the third side, because if you're asked different ratios to find, you'll sure as eggs need that other distance there on that missing side. Okay, yep, we could rationalize the denominator. Okay, so we're going from just one simple, well actually two simple little clues. Cos is a certain amount and positive, and sine is negative, so we had to work that through the whole triangle thing to find the third side, and we had to work it through which quadrant we were working in so that we could establish the size of the ratios, and also whether they're positive or negative in different quadrants. So loads to think about there. Okay, we're trying to solve this, and it's one of those, I think that's one of those exact values, so let's have a look. Yeah, tan 30 is 1 on root 3. It looked pretty exact. Anytime you've got a root 3 or a 2 or a 1, you might suspect an absolute value, or exact value, sorry, not an absolute value. So, tan 30, now you notice this goes from the range of theta here, it goes from 0 degrees right up to 360 degrees, so it's all 4 quadrants. So we can't just say that this is only going to be in one quadrant. Tan is positive, and notice that's a positive value they gave us for tan. Tan is positive in the first quadrant and the third quadrant. So we need final values for the first quadrant and the third quadrant. How do we get a value in the third quadrant? We take our basic value of 30 degrees and add it to 180. 180 plus will give us the equivalent to 30 degrees in that third quadrant. So we've got tan's positive in the first and third. We get 30 for the first quadrant and 180 plus 30, which is 210 for that third quadrant. Okay, this one looks a lot harder than usual, but if we divide both sides by 2, it'll look pretty normal. So we'll divide by 2, we'll just get sine theta left on the left-hand side, and we can write that as a fraction, minus root 3 over 2. Then that looks like an absolute, whatever I keep saying that, an exact value from our triangle. And we're also looking for where sine is negative. See how sine was negative in the question? These are the two quadrants where sine is negative, so we'll keep that up our sleeve. Try and find out the exact value. The basic value there is 60, gives us root 3 on 2. Check your exact value triangles there and you'll see that. Sine 60 gives you root 3 on 2. And we're looking for the equivalent of 60 in the third and the fourth quadrants. We'll get 180 plus 60 for the third quadrant and 360 minus 60 for the fourth quadrant. That's how we do that. So we will get 240 for the third quadrant and 300. So that's the equivalent of 60 in the third and fourth quadrants that we're working in. Once again, we won't be fooled by this because we just saw an example that's pretty similar there. We'll divide both sides by 5 and then we'll get more of a fraction, a traditional sort of method to work with here. So we'll divide by 5 and then we'll get a fraction. Now we can start making a bit of a thought there. Well, that's not an exact value type scenario. We've got a 5. 2 might be an exact value, but it needs to be fully a ratio of exact values, so that's not going to work there. We'll press Shift Sine minus 2 over 5 and see what we get. We get actually 23 degrees 35 minutes. Correct if we rounded it off there. Now we get a minus value there. Interesting. But the question wants us to consider all four quadrants there, but there's only certain quadrants where sine is negative. So when we check out all stations to Cronulla here, the third and the fourth quadrants is where we'll be working, because that's where sine is negative. So we need the equivalent of minus 23 degrees 35 minutes in the third and the fourth quadrants there. We'll have 180 plus 23 degrees 35 minutes and 360 degrees minus 23 degrees 35 minutes. That's how we create equivalent angles in the third and fourth quadrants. So that was 180 plus this angle up here, and this is 360 degrees minus this angle up here. That's how we created the equivalents in those two quadrants. Alrighty, now this is a whole heap different here. We can certainly divide by 2 to get out of trouble with the front number, but have a look at that. When we've got a number in front of the theta in these sorts of questions, it changes everything, I'm afraid, or it changes a lot anyway. So let's have a look at the adjustments we'll need to make when we think through this question. Let's divide by 2 both sides for a start, and we get this: cos 3 theta equals a half. So we'll have to adjust for the fact that we're doing 3 theta. Now theta goes from 0 to 360, so 2 theta will go to 720, and 3 theta will go to 1080. So we'll have to consider that all the degrees is from 0 through to 1080 here, because we're working with 3 theta. It's quite an adjustment we'll have to make. Alright, now first of all we have to have a think about what basic angle we have that creates a half on our exact value triangle. If we have a look at our exact value triangles, we see that 60 degrees is our basic angle there. And so 3 theta is going to equal 60. See how that's in that section there, and that's in that section there. So we're just making those equivalent to each other. We'll divide both sides by 3 and we'll get 20 degrees there. But anyway, cos is positive. Notice it was a positive value here. Even when we divided by 2, it remained positive. Cos is positive in the first and fourth quadrants. But see that first and fourth quadrants is only 1 lap of your all stations to Cronulla. We've got to consider 3 laps of this, because we're doing 3 theta in this question. So I made that point before. With 3 theta, we'll have to triple that 360 here. If we had 3 lots of that, we've got 1080, like I was saying before. So we've got a fair bit of work to do here. 3 theta. So 3 theta, if we're just considering that and just leaving it as this idea here, we have 60 degrees, which is the first quadrant, the first time around. So first and fourth quadrants the first time around. Then when you go another lap, you get first and the fourth quadrants the second time around by kind of adding 360 to it. So that gives you the angle that you'll hit in the right quadrants 1 lap later. Add 360. And then the first and the fourth quadrants here, that would be adding another 360. So get your teacher to explain this if you're not sure. It's quite an involved process. So we've got 3 theta, the results for that. Now in the beginning though, we want to find theta, so we'll divide everything by 3, every value. So we get the originals in 3 theta form, and then we'll divide by 3 to get the final answer there. So each of these values on this bottom line here is just the one above it divided by 3. Phew. Tricky. But you've seen one example. Get some more practice and get back to your local maths teacher. Okay, we're solving this. Now, this is a bit of a trick because we've got it squared here. Wonder what that does to our questions. Well, if we square root both sides, special things will happen. That'll cancel out the square on the left hand side. When we square root though, we have to consider plus and minus, like when you've got x squared equals 16. If we square root both sides, we get x equals plus or minus 4. Now that's interesting there as a quirky thing that might lose your mark, but here if the tan ratio is positive or negative, we're talking all four quadrants that are possible in this situation. This is how we need to respond. This means there'll be a solution in all four quadrants, which is going to keep us busy. So in what scenario is tan theta equals 1? You go to your exact value triangle and you'll see tan 45 is 1 over 1, or just 1. And so we've got 45 degrees in every quadrant. So we've got 45 degrees is in the first quadrant. What's the equivalent of 45 degrees in the second quadrant? Well, we'll have to go 180 degrees minus 45 for that second quadrant. We'll have to do 180 degrees plus 45 for the third quadrant, and 360 degrees minus 45 for the fourth quadrant. So we'll get 135, 225, and 315, I predict. Well, there you go. That's one I prepared earlier. Alright, so it's interesting there. Don't be fooled by the square. You can square root it, but don't forget about the plus and minus, because that means there's a solution to that question in all four quadrants. A bit different, isn't it? This one, okay, very similar. Let's divide both sides by 4 to get things on an even keel here. Then we're square rooting both sides. And when we square root a quarter, we get a half, but we have to remember it's plus or minus. So then we think, okay, sine a half, what basic exact value is that? Well, sine 30 is a half, so we need the equivalent of 30 in all four quadrants. So the first quadrant is 30, then we'll need to do 180 minus 30, so we'll get 150. 180 plus 30 to get the third quadrant equivalent, which is 210, and 360 minus 30 to get that fourth quadrant, which is going to be 330. So we get 150, 210 when we add it to 180, and 330 when we subtract it from 360. So a bit of a combination between those other ones where we had to divide by 2 or whatever. And then the square root. Anytime you're doing the square root on both sides, don't forget the plus and minus, and you're going to have to look for some more solutions. They're going to be in all the quadrants. Alright, tricky one. They're all tricky, aren't they? This one's interesting in its range that it wants, from minus 180 right through to 180, and it's given us an exact value version there. So once we crack the code to figure out what basic angle theta must be to create minus 1 on root 2, that'll help. And interestingly, we sort of think of the 0 being here, and we're going from 0 to plus 180, and also around this other direction. We still sort of cover all four quadrants in a way, but still. So we'll think about this. Cos is negative, so we've circled in green the quadrants where cos is negative. So all we need now is, the basic one there. 1 on root 2 on the exact value gives us 45 degrees as a basic angle. So we need the 45 degrees equivalent of the second quadrant there, and the 45 degrees equivalent for the third quadrant. So cos is negative in the second and third. 135 for that one, and minus 135. So it's kind of like we'd have to do 180 minus 45 for the 135, and 180 minus 35 again, but it's almost like minus 180 minus your 45 for that 130 minus 135. A bit trickier because we've got a bit of a different range of theta values there. Okay, now this is looking at the sine curve for this. I just wanted to remind you what that looks like. It starts at 0, it goes up to 1, and down to minus 1, and there's one sort of loop of a bit of a curve here. Goes through the axis at 180 degrees, and completes one sort of complete move, one sort of wave of sine length in 360 degrees. So that's your basic sine curve. Cos doesn't start from 0 there, it starts from 1, still goes down to -1 down here, and finishes back up at 1. So that's what the basic cos curve looks like. Now here we've got a couple of adjustments to make. This number here, it's called the amplitude. Instead of going up to 1 and down to -1, this being a 2 affects it in terms of the curve having to go up to 2 and down to -2. That one increases the amplitude if that's a normal number bigger than 1. And this number here tells us how many normal sine curves we can fit where there usually is 1. That's how I think of it. So that's what it looks like. You notice this is 2 and -2 there. That's the effect of that 2 in front. And we have, instead of one big up and down and finish, we have, I'll do this in a different color just to show you. I'll do this in blue. We have one sine curve here. That's one of them. This is the second one. Like kindergarten, follow the line here. That's the second one. Then you got another one, the third sine rule, in the same space where we used to have one sine rule. That's how I think of the effect of that 3 there. It's like 3 sine curves fitting in the space there used to be 1. So that squishes it up really. All right. A whole bunch of examples there. Thanks for your patience. That was quite a long video, and I hope that helps. There's a lot of tricky stuff there, including pluses and minuses and quadrants all over the place. Exact value triangles are handy to know, but all the best. I hope that comes together for you. See you next time.